Hello everyone. In this video we are diving into a practical data science project that is predicting airline delays. Delays are a significant inconvenience for travelers, and understanding patterns behind these delays can be incredibly valuable. Let's explore how data science can help us tackle this problem. Let's overview our project. Our objective is to analyze factors affecting flight delays and build predictive models for improved air traffic management. Dataset: comprehensive flight data from major USA airlines, including departure, arrival times, and weather conditions. In this project, we are using a dataset of flight details to predict whether a flight will be delayed. Our goal is to uncover patterns in the data and use machine learning to make accurate predictions. We will walk through data loading, cleaning, exploring features, and building predictive models. Now, let's see our project. Let's see our codes. Here, first, to start a project, we have first imported all important libraries. As we can see here, we have imported all libraries here. Next step is to load our data, that is our CSV files of flights data. We have done it here. Let's now overview what this file contains. So these files have many features like year, month, day of week, flight number, tail number, destination, airport, and many features. It has 31 columns, as we can see it here. Let's see data type of all features containing flight file. This is the data types. These are the data types of every feature. Next, now we have used different codes to analyze. Now the main thing here is to identify null values. To see null values, we have used this code here. This code gives us null values of every feature. Like we can see in tail number there are 14,721 null values. So we have to first handle these null values to make because if our data is not clean and it contains null value, it cannot the model cannot be applied. So as we can see, we have 3,46,05,274 null values, total null values in our data set. As our data set is very large, so first we have to deal with these null values. So to deal with these null values, what we have done is, first we are dropping some columns which we can think is unnecessary for a predicting model, which is logistic regression. We will use logistic regression to predict the airline delays. So we are dropping these columns, as we can understand that these columns will be not be necessary. As we can see year, we have only 1 year of data, that is 2000, of 2015 only. So we don't need this column. Likewise, these all columns are unnecessary, so we have dropped these columns. Next step we have taken is to deal with null values. To deal with null values, I had used simple imputer, which is helping us to impute mean of each feature to its null values. We had applied this code. After this, we can see that we have no null values. We have 0 null values in our data set. So we had dealt with null values. After this, we had checked for duplicated column. So we can see there is no it is giving false. That means we have no duplicated values. After this, as we can see, our data set is very large, so we are using only 0.5% of the data set. We are using only 0.5% sample of our data set, because I had tried with more with large sample size, but it was not working in my Jupyter notebook. That's why I am using very small sample. After this, here till here our data cleaning is done. After this, we are done visual representation of our data. Like here I have showed a histogram of every feature of data set between frequency and feature. Here I had here I had performed on histogram only on airline and their airline delays, average airline. After this, these all are just these are visual representation of our data. Like here we can see this is an histogram between, it is in correlation between numerical features like distance, schedule time, arrival delay, departure delay, and everything. This is an scatter plot. This is an heat map of arrival delay with month, according to month, and it's giving average arrival delay of every day and each month. After this, we are creating a target variable, that is here I had named it is delayed from our arrival delay. This function is what this function is doing. This function is actually doing that the delays which are greater than 15 minutes are categorized as 1 and else are all 0 as zeros. So we have created our target variable. Now we have created another column, departure R, from scheduled departure. Here we are extracting only R from scheduled departure in departure R. And then we had created two features, one categorical features and other one is numerical feature. In numerical feature, all features contain numerical values are kept, and in categorical feature all features with categorical values are kept. From here we had created our xy variables to and here we had splitted our data in training and testing data using we have given a proportion of 80 to 20%. Now this code is very important because we are using we will use this code from now here many times. What this code is doing, this code first these lines are doing these lines are converting our categorical features into string type, because machine learning models works on string type more efficiently. After this, what we have done is we have created a object of column transformer, naming it preprocessor. After this transformers, what this transformer do is it takes tuples of list and runs it one by one. So first it will run this tuple and then it will run this tuple. What this tuple is doing is it is applying standard scalar on numerical features. Now standard scalar standardizes our numerical values and minimizes and standardizes variance points. After this we are applying one-hot coder on categorical features. One-hot coder helps in us in converting categorical features into numerical features. After this we had created a pipeline. Now pipeline helps us to run multiple steps in a systematic way. Here it will first run preprocessor, which we have defined here to for data transformation. Then we will apply our model classifier, that is here we are using regression model. After this we have fitted our model on our training data. After this we have tested our data set, and we had printed our classification report. This method is printing every performance, or we can say evaluation report. Like accuracy, we can see accuracy of this model. We had achieved accuracy of 0.99, which is 99%. After this, to optimize this model, we are using VIF, variance inflation factor. It applies only on numerical features. So using this we will get to know which columns are among these columns, which columns are not that much important. So let's see, we had applied on numerical features VIF, we had written this code, and we get this. As we can see, there are with very high VIF, like month 35, wheels on 35. So we will remove these features which have very high VIF. So here I had make another feature named numerical feature 2, in which I had removed every feature which has high VIF values. After this I again applied our regression model on the data set, after removing unnecessary columns. So we can see that this is used to optimize our model. After this I also applied grid search CV. What grid search CV is, it provides our best hyperparameters which we will use in the model. So here this code is same as above. Now here I had make a variable param grid, which is providing parameters for grid for the model, like classifier C. And after this I had applied grid search CV. Here our grid search CV is applied. After this we had taken out best hyperparameters. It provided us best hyperparameter. It is saying that best hyperparameters for our regression model is classifier CV, classify C as 1, and classify penalty we can use L2. And also we had printed this classification report also. We can see it here. After this, to compare, like we have used logistic regression model. Now we have to compare it with another model. Like it's not that logistic regression model is the best model, so we are using different models, another model to compare it with. Like here I had used decision tree classifier. I passed the code to apply this. Here I applied the model on the training data set, and here we had tested the model, and here is the classification report. Now we can see accuracy here. Decision tree classifier is providing 100% accuracy in compared to logistic regression model, which were providing us 0.99%. After this I had also applied grid search CV on decision tree classifier. Here are the parameters. and it's also had given us best hyperparameters for decision tree classifier. These are all the best parameters it is giving us. So with these I had applied grid search CV on our model, and here our code is complete. Our code is complete for the project. Now let's see, and this is our PPT. So conclusion, let's go on the conclusion. Key findings are model performance, decision tree. As we had seen, decision tree outperformed logistic regression, offering better predictive accuracy. Future work, we can explore ensemble methods and incorporate real-time data for improved predictions. So here, this is all this was our project all about. So thank you.